let's talk about it. So this is the quiz question, quiz number 10. And that map, let's draw that little map here. Great, okay. Like that, and then right in the middle. Like that, and it's A, B, C, and D in the middle. Okay. Come on. A, B, C. Did you find out what happened?
Yeah, because I forgot you couldn't repeat it, so that's fine.
4, 1, 2, 8, 9. Okay, so nearest neighbor. Okay, so they want us to start at A, and of course end at A because we're making a loop. We're going back home. So, all right, so if you start at A, so you start here at A, who's your nearest neighbor? Who's the closest? Who's the lowest? Oh, I'm not showing you anything. Sorry. Let's go here. All right, so you start at A. Oh, I got to plug in the other thing. I cannot believe all this tech that I do now. It's just crazy. I used to write on the whiteboard, and people had a physical book in their hand, and that was that, you know? Now it's like tech time, a little tech show. All right. Okay, I'm here. All right. Are we good? I'm seeing nothing. Come on. Let's go. Oh, I'm on the wrong thing. Look at the laptop. All these buttons. There we go. All right. So there's the thing, right? And we're supposed to do nearest neighbor, start at A, end at A. So if you start at A, right up here, who's your nearest neighbor? Who's the closest connection? D. Oh, I didn't put a number for D. What was the number for D? 5. That one was 5. On the looking back at the original, I forgot to put that one in there. So the closest is actually C, right? Because it's only 4.
C, yeah.
Yeah. So it's only 4. So go like that. That's lower than 5 or 9. You with me? This is really easy if you get the hang of it. Nearest neighbor just means go take the lowest road, cheapest road. Now, don't be thrown off by how long it looks up there. That's has nothing to do with it. That's just a drawing, but the numbers are telling you how long the road really is. So that's your nearest neighbor. So go A to C, and then from C, where do you go next? What's the lowest path from C? Well, the D. It's only 1. That's a 1 here. That's the lowest road, right? Cheapest. It's cheaper than 2, right?
Well, actually, wouldn't it be?
I'm not talking about overall. Don't think something different than what I'm saying. I'm just saying if I'm standing at C, and I'm saying I'm here at C, I can either go the 1 road or the 2 road. What's the lower number? 1. No, don't think any deeper than that. We'll do some deeper methods, but not this one. This one simply says where you're standing, look at the roads, take the lowest one. That's all it means. So I'm standing at A, I can go 9, 5, or 4, I go 4. I'm standing at C, I can go 1 or 2, I go 1. Now I'm at D, that good? I'm standing at D, I don't have any choice. There's only 1 city left to visit, right? I've been to A, C, and D. There's only 1 city left. It's B. I got to go to B, and I got to go home. Because you got to make a loop, right? You got to start and end at A. Does that make sense? When you've only got 1 city left, you got to go to that city and go home. There's no other choices as far as numbers. Don't even pay attention to the numbers. Does that make sense? So what was that road? That was A to C to D to B and then back home to A. Right? Now, let's go back to the multiple choice answers. Wherever they are. Which button do I push? This one. All right. Back to the multiple choice answers. Which one of those is A, C, D, B, A? None of them. So grab none of the above. No. Remember, it's reversible. Remember, it's the same road. They can say that then this, it's good. I wanted to do this on the quiz on purpose because quiz points are not worth much. Test points are worth a lot. So I want you to not be fooled on the test. That's what I really care about, is that you got it good for the test. So for the test, remember, whenever you get an answer, it's the same as, and then just reverse it. Just start on the right side and go right to left. So A, B, D, C, A. Either one of those answers is really the same loop. Do you see what I mean? You could start here and go B, D, C, A. That's the same loop, isn't it? It's just running that loop backwards. It's the same way of visiting those cities. It's going to be the same total cost for that trip, adding up all those roads. They're the same roads. So whenever you get an answer, remember that on the next test on exam 3. Whenever you get an answer, list it forward and backwards and look for that answer on the multiple choice. I think this one was answer C, wasn't it? So that's what I meant by the forward backwards thing. Is that good? Does that make sense on that? So if it fooled you today, it won't fool you when it really counts big. You get half credit even just for being here clicking something. You know, you get 5 points. And I always do those free ones at the end, so you'll get a good grade in the quiz area. It's the tests that really matter, that you know that for the tests. Good? Any questions on that? All right. We have got a test back and stuff. So this is more regular. So here we go. Oh, I should have made that bigger, huh? Yeah, I'll redo it and make that bigger. And then we just want to find, right, okay. And then find this with D. Let me see what the, oops. It's not. Wait, that's the same thing. There we go. There we go. All right. So what was the question? Find the nearest neighbor starting with C. Okay. So here we go. They basically want us to take this. You want to copy that down on your papers there? You can copy that down. So they want us to do the nearest neighbor thing starting with C. So they want us to start with C. So that means right here. So the question is off the screen now, but it says do nearest neighbor start at C. So that's basically what it says. Do nearest neighbor starting at C. So that means we're going to make a loop. We're going to start at C, hit all the other dots, come back to C. And at every point, remember what we're trying to do in this chapter. We're trying to say, what's the cheapest way to do this? Right? If this is FedEx and they have a bunch of roads and they deliver a bunch of products, what's the most efficient way, wasting the least amount of time and gas and all that to visit all the dots? Okay. So we're trying to come up with the best way. Remember that stuff we did with our calculators? We proved that even a supercomputer couldn't do the whole problem very efficiently. We need some trickier ways, right? Did that make any sense? We said, hey, why don't we just have a computer check every possible way? Every way of visiting all those cities, and it was just too much. It was just too much even for a supercomputer. It would take it 800 years or whatever. So we need to be more tricky. So here's our first. We're going to have like three different ways of doing this. And none of them are perfect, basically. So here's one of them. Start at C and do nearest neighbor. Like at every point, go to your closest neighbor. So what neighbor is closest to C? What's the...
B. Oh, wait, different one. My bad.
D for dog, right?
Yeah.
D is the cheapest, right? Because if you're sitting here at C, you could say, I can go this way for 20, this way for 36, this way for 47, or that way for 22. So the cheapest is going to be D for 20, right? That's your nearest neighbor. Now, this is not necessarily the best overall way. By starting with nearest, you could end up wrecking it. This isn't perfect, right? This is just one way of getting a, hopefully, somewhat decent answer. Okay, we've kind of given up on getting the perfect answer because the computers take too long to do it. There's just too many routes. Okay, so first thing is we go that way. So C to D. So I'm going to list it over here. Go C to D, like that. Oh, and they're going to ask us how much it costs as well. So what did that cost? 20, right? C to D road was 20. And now from D, where do you go from D? What's the cheapest road from D? Yeah, 34 to E. 34 to E. And now from E, what's the cheap? I don't want to go back. You can't go back to ones you've already been. You only visit every city once. So I have two options. The 26 is the better, the B, huh? Go to B. And that road is 26. We good so far? I'm just taking the cheapest road, going to the nearest neighbor every time. And now, from the B, I don't even need to look at the numbers. I've only got one city left. You tracking with me? There's only one city left to visit, and then I have to go home, right? I've already been through 4 of the cities. There's only one city left. So don't worry about the numbers at this point. You have to go to that city, and you have to go home. So you have to go to A, whatever it costs 24. And then you have to go home, which is back to C, whatever it costs 47. And we're done. So that's the nearest neighbor plan, which may be a pretty good plan. It looks pretty good. It looks like it's fairly cheap. We avoid most of the big numbers. So it's the nearest neighbor plan starting at C. Does that make sense? We're going to learn different techniques of trying to get a cheap plan. This one's nearest neighbor. All right, so add up those numbers. I don't know what they add up to be. That's the total weight. They call it the weight. You know, the cost, total dollars or miles or time or whatever it is. Was that 54, 74, 80, 151? I think it's 151 if you add those up. Does that make sense? How we did that? Just choosing the nearest neighbor every time. Okay, so let me go back now. But now, the second part, they're going to say redo nearest neighbor. Start at D. So now they want me to redo the nearest neighbor thing starting from D. So let me erase what we got here. And I'm going to put a dot on D. We're going to start and end at D. Okay, so start there at D. So go ahead and try it again. So go ahead and do the nearest. Let me let you do it. Go ahead and start from D and take the cheapest road you can every time. The cheapest road you can every time. Just connect them up like that. Are we doing okay? Let me jump in and help. So if you start at D, which one are you going to go to next? Go this way to C for 20. Are we good there? And then from C, where are we going to go? Looks like B, right? B for 22. And next, the A for 24. It's kind of going around the horn here. A 24. At this point, I visited 4 of the cities, right? I've only got 1 city left to go to. Is everybody tracking with me on this? Once you've only got 1 city left to go, there's really no choice. You have to go to that city and then go back home. So where am I going to go from A? I'm going to go to E, which costs 27, and then I'm going to go back home to D, which costs 34, because I have to make a loop. Is that good? And then what's that? Oh, they don't even ask us for the total, so I'm not even going to add that up. Does that make sense on that being the path, the nearest neighbor path starting at D? Because I'm about to do something with it. Everybody with me to that point? How they ask you to answer it on the test, on the homework and same thing on the test, is they say rewrite it starting with C. So now, rewrite. This confuses students sometimes, so let me show you. It won't be hard. Now rewrite starting with C. So now take this loop. It's a loop, right? It's actually a circle. It's just the outer edge circle. Rewrite it and start with C. Because for whatever reason, they just want the answer, the same loop, written starting with C. So same loop. If you start at C, where would you go? Well, B, A, E, D, and then back to C. You with me? That's the same loop, huh? That's going to have the same total if you added all the numbers up, right? It's really the same path. It's the same way of visiting the 5 cities. It's just starting at a different place in the loop, but it's the same loop. Or if it's a test, a multiple choice test you're taking, like we'll take next week on this stuff, you could run it backwards. So I'd also run that backwards like that, So C, D, E, A, B, C. I just ran the loop backwards. So I have it forward and backwards, same loop. We're just running it clockwise or counterclockwise, right? That's those two are the same as the original D loop. We're just starting and ending with C now instead of D. And that's how they want you to enter the answer. Does that make sense? Is that okay? They're going to do that to us all the time. They're going to have us rewrite our loops. They'll say rewrite it now, starting with a certain spot. Okay, we good? So I'm going to move on from that question if you're all good with that. Okay. Okay. Can you all copy that one down okay? Put all those numbers in there. Now they want us to do nearest neighbor starting with B. So start with vertex B and do the nearest neighbor thing. So go ahead and start with B. So I'll just leave it up there. So starting at B. Start at B here, start at B. And so who's the, from B, who's the closest, what's the lowest number coming out of B? Yeah, it's up here to A, the 3.5, huh? So go ahead and write it down. We need to have the total because we're going to compare them. We're going somewhere with this. So write down the numbers. So there's the A. And now from A, what's the lowest number coming out of A? Yeah, it looks like it's this C number here, huh? Well, I'm not doing that very neatly. So from B, we go this way. And from A, we go this way down to C. So from A to C, and that was a 3.3 cost. We good so far? And now from C, where do we go from C? E would be this way, huh? To E. And that's 2.4. Is that okay? Like that? And then finally to what? Oh, at this point, we have 4 cities, huh? We have 4 cities and there's only 5 total. So you have no choice. So I say that, I keep emphasizing that because I've seen people, at least when I first taught the course, they'd waste a lot of time at this last step. When you've only got 1 city left, you don't need to even look at the numbers. Just got to go to that last city, got to go home, right? So because we have 4 cities, there's only 1 city left. So which one is it? Which city have I not listed up here? D. D for dog. It's got to be D. So don't even waste any time at all. You've got to go to D no matter what the number is. You've got to go down to D because you got to hit all the cities. That's 2.6. And then you got to go home. Where did we start? We started at B. So then you got to go back to B. No matter what that road costs, you got to take that road back to B, which is 4.0. Okay. Add that total up. What is that total? These guys. This is 6.8 8.8, 9.2, 11.8. Is it 15.8? I think. You may want to double check me on the calculator. I think it's 15.8 is the total cost. That'd be like how many miles or whatever for making that loop. On that. Is that good? Is that okay? So that's nearest neighbor starting with B. Now what they want us to do, say, got it right? Okay, thanks. Is also do nearest neighbor starting with C. So let's do that. Let's go down the list. Now let's start with C. So restart, do it again, start with C this time. It's going to be a different path. And do nearest neighbor starting with C. So I'll let you do that. Start with C. If you want to move ahead, they're going to have to do all these. They're going to have to do nearest neighbor start at C, start at D, start at E, and then even A. We have to go back to A. So we're going to do 5 nearest neighbors, and we're going to pick the best one as our loop. And then we're going to rewrite it, starting with, I don't know what, some other letter. So these are a little tedious. 5 nearest neighbors. Feel free to check those around, Jeff.
Suppose it be, is this the question? Oh, yeah, I skipped that one. Supposed to really check. Has to be D, 4,026. Oh, there's one part remaining. Yeah, I could go back and do that.
It's just not as important as other things. Yeah, I'll go back. But, yeah, I encourage you to try this one. This will be like what's on the test, for sure. Let's do okay. It says. Feel free to chuck those around, Jen. So starting at C, and I'll erase what we did. Starting at C. Who's the closest link to C? Isn't it E? Yeah, it looks like E to me, right? C to E, and that one is 2.4. And then from E, it's what, down here? 2.6 to D. And then, yeah, 4.3 up to A. And now at this point, I've done all but one city, huh? Once you've only got one, I got 4 cities in my list. 4 cities, C-E-D-A. So that means there's only one missing, right? There's 5 total, so only one missing. So when you only have one missing, don't even think about it. Just go to that city and go home. So who's missing? B, I've got to go to B, and then I got to go back home to C. C was where I started this loop, right? You always got to, we're always closing the loop. Got to go back home. So A to B is 3.5. And then back home to C is 3.6, is that what it is? So add those up. 7.1, 11.4, 12, 14, is it 16.4, I think? So that total loop costs 16.4 miles. Is that good? Now let's do it again, starting with D. So now start and end with D. We're just trying to find the cheapest way we can to connect all these cities. Okay. So I'm gonna move along if that's okay. So starting at D. So what's the cheapest? Looks like B, right? Go that way to B, and that'd be 2.6, and then from B, what is it? Oh, the 2.4 to C, 2.4 down to C, and then from C, yeah, 3.3 up to A. A3. You got to write down the numbers too. At this point, I have 4 cities. There's only 5 total, so I just got 1 more. You got to go to that city. Who's missing? What's the only city I haven't visited? E. You got to go back to.
No.
Wait a minute. Did I do something wrong?
It's
B is supposed to be switched with B 4.0.
Did I mess up in the
the
beginning?
second is B.
Yeah, from D to B, that's 4. 2.6.
Oh, no, but I want to go B. B's cheaper.
No, it's
E.
no, it's B is B.
What's that?
B is on the other side.
Oh, 3.
I'm sorry. I'm
You
confused.
want to go C to E, not C to A.
Oh, really? Did I mess up there?
Because C to E is cheaper. It's 2.4. C to A is 3.3.
Where is E?
It's on the left.
Oh, that's E. I got some mark over it. There it is. There's my problem. No.
C to E.
Oh, I messed up. Sorry. My thing's all scribbled up. All right. Sorry, guys. Yeah, okay. Let's go back. Yeah. Okay. So, yeah, so it should have been started D. Should have been E. That's an E. I see what y'all are saying. That's E. It looked like B on mine. This is marked up. All right. So that's, yeah, C to E. I mean, D to E to C. That's all the same. To A, 3.3. And then from A, yeah, you got to go, last city's B, huh? That's what y'all are saying. Go to B, and then you got to go home to D. So from A to B is what, a 3.5 connection, and B back to D is the 4 connection, right? 4.0. Add up those numbers. Maybe I shouldn't do blue. You can't really see it.
15.8.
Is that what it is? 15.8. You know, see how it's the same as this number up here? They're probably the exact same loop, just starting at a different point in the loop. Probably. We'll figure that out in a minute. But anyway, let's keep going. Is that good? Now, finally, no, not finally. We got 2 more to go. These are long and tedious. So 2 more to go. So now we got to start with E. Start with E. Do the cheapest loop. I'm just going to whip them out if that's okay. So start at E. What's the cheapest road from E? B to C. 2.4. Then people get confused. It's all because everybody can do the connections, you know. That's not the problem. What confuses people in this section is they get confused between the rewriting and stuff. So as you look at those, remember this fact. Any loop can be rewritten starting with any letter, right? So it's nothing magical about what letter you're starting with. Just pick the lowest number. What's the lowest number? Well, 15.8, which occurred 3 times. 15.8 occurred 3 times. Are those 3 all the same exact loop? Yes, they are. How do you know? I'm looking at the order and counting the letters down. What do I mean? Look. For example. Well, let's do this. Let's take. Here is the answer. Already in terms of B. See, there it is written starting with B, right? But there's another way to write it. Or how else could you write that loop?
B to C.
Run it backwards. Remember, you could start here and go boom, 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 right? So B, D, E, C, A, B. That's the same loop, just run forward or backwards, isn't it? So either answer could be on the multiple choice thing. Now, look at this one for a minute, guys and gals. I could take that other 15.8 and I could write it starting with B. So if I start with B here, and you could go to the right or the left. I'll go right. D, and then where do I go from D? Well, you're back at this D, right? B to D, you're back to this D, E, C, A. E, C, A, back to B. Do you see how this and this are identical? That's the same loop. This is the same loop. We just listed it starting with D. Here we listed it starting with B. Those are the same loop. They're the same circle. They just started at a different point in that circle. Do you see how I figured that out? I just started with B because they told me to make the answer start with B. And I just went D, E, C, A. You could have gone backwards. B, A, C, E. And that would have been this one. B, A, C, E. See it? Same loop. Those are all the same loop. All those 15.8s are the same loop, just starting at different points. And they want the answer to be given starting with B. So we can give it this way, or we can give it this way. That's forward and backwards, starting with B. Either one of those is the right answer. We'll go look for it now on the multiple choice. Does that make sense? BAC, so BACE, base. D. What we just did, what this is called, I can write it somewhere here. This is called repetitive nearest neighbor. Because we repeated the nearest neighbor thing for every letter. Does that make sense? We did 5 nearest neighbors, didn't we? And then we took all the answers and wrote them in terms of B at the end. Well, we took the cheapest ones and made them in terms of B. That's called the repetitive nearest neighbor method. So what you'll see on the next exam next week is it'll say do repetitive nearest neighbor. And that means you've got to do nearest neighbor starting with each of those 5 letters and rewrite it when you're done. Like that.
So it's basically like, let's say I start with A, you pick the shortest route.
Yeah.
And the same thing would be shortest route because
That's
you
right.
start at a different point, different.
That's right. Get a different route, perhaps. That's right.
That's all I need to hear.
And then we'll be off to another problem. So there's one wrinkle right at the end. I'm not even going to blow that out. We're not going to do the whole thing. I've already done it for you, and there's the answer. You know, so if you wanted to look back at this YouTube and check it out later, I've done it, and there's the answer. But so it'd be the same exact thing we just did. See the words there, repetitive nearest neighbor, right? So that means you got to start at A, do nearest neighbor. Start at B, nearest neighbor. Start at C, nearest neighbor. Start at D, nearest neighbor. Start at E, nearest neighbor. Got to do all those nearest neighbors. Pick the best one, the lowest one, and rewrite it starting with A. And so there's the answer right there, starting with A. That's nearest neighbor starting with A. Now, they're going to ask you for the bus cost for the tour. Well, if you go up here and trace it, starting at A, if you go to C, see that road from A to C? I don't know if you can see it up there. It's 185. So here, let me make it bigger. A to C to E to D to B to A. So from A to C is 185. From C, I'm just taking the final answer. I've already answered the question, just showing you how you finish the problem. C to E is 340. E to D is 305. D to B is 165. And then back to A is 205, right? So if you add up those numbers, somebody add those up? Oh, I can tell it's going to be 1,200 because of something else. It's 1,200. You should get a total of 1,200. Now that's not the final answer, though, to the question. Look what the answer is. It's 9,600. That's how I was able to figure out the 1,200. So look at the 9,600. Why is the answer 9,600 when we're adding those? We add those up.
We're talking about the bus fare.
Yeah, because this is miles, huh? This is how many miles. And remember right here, it costs them $8 for every mile. So you take that times $8 per mile. And that's when you get the $9,600. That's it. So when you're all done, you add up the cheapest thing. Just multiply by 8. That's all. Just wanted to show you that. Just multiply by 8 because it's $8 a mile. We good with that? Can I move on from that one? So that would just be repetitive nearest neighbor again. At the end, add them up and multiply by 8 for the $8 a mile. All right. Okay. So they want us to do something called cheapest link. Let me look at my notes, make sure I can say it in the best way. on this. Well, I think I remember. So we're going to do. So let me. The method number one. We've got three methods so far. Well, I guess method number one was really brute force. And we'll come back to brute force. That's where you just list them all. It's too long for even the supercomputer. Method number two is nearest neighbor. Method number three is repetitive. Nearest neighbor. And now, finally, this is our last one. Method number four, cheapest link. Let me get that door. Okay, so I don't know if you've been keeping track, and I will go over this again as we're moving on, well, especially next week is on the practice exam. These are the four methods. This is the main thing we do in this chapter anyway. Next exam we'll have 2 chapters. This chapter, the main thing is these 4 methods. But what are we trying to find? The cheapest way to visit all the dots. So brute force, the problem with brute force was it takes too long even for the fast supercomputer. What's the difference between nearest neighbor and repetitive nearest neighbor?
Nearest neighbor is like just whoever's the nearest, right?
Just start with one dot. Like, so they'd say, hey, do nearest neighbor, start with A. And so you just do it once. Repetitive is then you also do it starting with B and C, and like we just did in the last one, right? You do 5 nearest neighbors and then pick the overall winner. So it takes longer, but you tend to get a better answer. Everybody see that difference? So there's nearest neighbor, which is just do it once. And repetitive nearest neighbor, you do it once for every dot. 5 times, a lot more work. Now, the final method we're going to do, this is the last one in this chapter, is cheapest link. It's a whole special way. And what you do, here's the method. Number 1, you pick the lowest number anywhere. You're not tied down to any particular dot. You go anywhere you want. You look at the whole map. Like right now, I would look at every number up there. Not just starting from A, but anywhere. Anywhere at all. Just look up there. What's the lowest number on that entire display?
155.
Looks like the 155, right? 155 is the lowest number up there, right? Isn't that the lowest number on the board? So that row, which is the road from A to B, that is for sure a link, a road, that I'm going to want to use if I'm trying to do this thing in the cheapest way possible. Does that make sense? Yeah, you just keep picking you start with 155 and you say, hey, I want that one. That's the cheapest road. What's the next cheapest road?
180.
The 180. Then you pick the 180 and you say, hey, that's the next cheapest. I want that road.
205.
What's the next one? 205. Where is it? Oh, yeah, up there. 205. I want that one. That's the next cheapest road.
255.
Next comes 255. I want that one. That's the next cheapest road. What's the next one? 310. I want that one. Wow, that worked great. They made this one super easy. They don't always come out that nice. I was going to explain about harder things, and it didn't do anything hard. So that looked like it was cake. It's not always that way. I'll explain. But yeah, you just pick the cheapest one every time. The problem is, sometimes the cheapest one won't make a loop. Then you got to figure out what to do. That's the other step. So generally it's just, hey, pick the cheapest road anywhere you want. But there's 2 reasons why you might not want to take a road and you have to go up to the next higher one. And that would be, number 1, do not make a loop too early. Too early. Leaving out one city. Right? Does that make sense? So for example, let me go back. What if I was doing this and you picked this one was the cheapest and then this one and then that one? I know they're not. But what if the numbers were that way? What if those were the 3 cheapest roads? Could I just grab those 3 and say, hey, there it is, that's good? No, that can't be the loop because we never went to cities E or C. See what I'm saying? You have to watch out for that. You can't pick a road if it prematurely makes a loop. If it makes a loop before the end. You can't do that. And there's one other thing you can't not do. Do not, well, instead of only, only 2 roads connect, I guess, connect to every city, not 3. Not 3. In other words, so I'm showing you the 2 things you cannot do. So basically, cheapest link just says, hey, pick the cheapest, then the next cheapest, and the next cheapest, just go up the line. But, and this one was just smooth as butter, but in a minute we'll see one that's not smooth as butter, where something bad happens. And one of the bad things that can happen is you can make a loop too early. The other thing is, what if these 3 right here were the cheapest roads? This one, and this one. What if they had the 3 cheapest numbers? Could I just pick those 3? No, you can't do that because you have 3 roads hitting A. You can't, well, why could that never be the answer? Well, we're making a loop, which means you go into every city once and come out of it once. You don't hit it 3 times, you hit it twice. Otherwise, you're not going to be making a loop. Does that make sense? You only want 2 roads hitting every city. So never pick one that has three hits on a city and never make a loop too early. Other than that, just go for it. Pick the lowest, the next highest, and up the line you go. That's called cheapest link method. Does that make sense? So let's actually do it one more time. I did it quickly. Let me do it slower one more time. The main thing that hangs people up with this is they get kind of used to starting. Like they'll look at like a certain dot and think they have to start with that dot. You don't. Remember, cheapest link is global. You're looking at the whole thing at once. You're just saying, what's the cheapest number anywhere? 155. So so that's my first road. So you just go, all right, I'm going to take the AB connector at 155. So I'm going to actually do the cheapest link thing. Here, let me just change the color so it's more obvious what I'm doing. So I'm going to do the 155, the AB connector. Next, I'm going to do, what's the next cheapest number? It's the 180. So that's the EC connector. EC connector. What's the next cheapest number? 205. Right? That's the EA. So I'm going to look at this. I'm going to connect this back to A. See how that E is going back to A? I'm kind of drawing it as we go with my letters. Everybody see this? This is no big deal on this one, but when they get hard in a minute, you'll want this little technique. Do you guys see what I just did? I wrote A connects B, E connects C. Those were the first 2 rows. And the next one, well, and then I noticed E goes to A. So I didn't draw a new EA. I just drew an arrow because I already had E and A on my list. So I just connected E with A. I'm making a loop. Is that confusing? I'm going to put them all in one line in a minute. I'll just follow the loop. I'm just doing this to keep it organized. Okay, so what's the next cheapest I got? 205 was my last one. What's the next cheapest number? 255, right? Yeah. D to C. Now again, don't just write down DC. Why not? Because I've already got C. C's already on the board. So just connect to D somehow. However you want. Up, down, right, left. The direction doesn't matter at all. Just that you know D is hitting with C. Right? That makes sense. And now, what's the next cheapest number? 310, which is D to B. D to B. Boom. That's a loop. See how that's a loop? Write it any which way you want. Start with any letter you want. That makes a loop. So like I could write it starting with A, for example. I could go A, B, D, C, E. Back to A. Or you could write it backwards. Or you could write it starting with B or C or D or E. It's a loop. It's that loop. It's the cheapest loop on them. It's got to be at the 5 cheapest numbers.
Will it ever tell you to start with A and then do that? Or start with B and then do
Well, cheapest link, they won't. Because cheapest link you can start anywhere.
Okay.
But they might ask you to write the final answer that way.
Okay.
Yes, that makes sense. It's a really good question. Nicole's on. So everybody catch it? Because that's what I think really, and over the years I've noticed that's what confuses people about this material. They'll look at the multiple choice answers, and they'll see they're all starting with A or something. And they'll go, oh, I have to start with A. No, that doesn't mean the method starts with A. It just means start wherever you want. In the end, rewrite the answer starting with A. Make sense?
Because it's in a loop, it doesn't matter really.
Right, because it's in a loop, it doesn't matter. That's exactly right. Is everybody getting that? So I think people get thrown off by the multiple choice stuff. They look down, they see the answers are all A, and they think they have to do the method starting with A. No, that's just the rewrite of the final answer. Because it's a loop. We can rewrite with any letter. That's right. Good. All right, let's try one where it's not a no-brainer. Like that was a no-brainer, cheapest link. So there are harder ones where you have to watch out for the no-nos, the two no-nos there. Okay. Yeah, so the quiz this morning was question 23, right? We did nearest neighbor. How did we know where to start and end? Not by looking at these answers. The answers could be rewritten with anything. But up here it said start at A. See it? That's how I knew. Up here in the words it said starting and ending at A. So that's what told me I had to start. So when they said do nearest neighbor, I realized, start at A, go the cheapest road, and that was the 4, and then the 1, and then the... Well, we can't do the 5 because that would do the loop. So we had to go the 8 and the 9. Yeah, anyway, so that was nearest neighbor. Notice question 25, repetitive nearest neighbor. How's that different? I'm not going to do it right now, but we just did it twice, right? But I want you to see, this is exactly how the test will look, Probably like verbatim, basically. I'll give you 4 dots. Map, and I'll say, give me nearest neighbor, cheapest link, repetitive nearest neighbor. So how is repetitive nearest neighbor different than nearest neighbor? Answers all look the same. They all start with A. But that's just the final rewrite, right? Don't be fooled by that. People some people think they can trick the system and just like just add these up and pick the cheapest. That won't work, because that's not necessarily the one. Even if you think, well, I got the cheapest, it's got to be the one. No, the method doesn't guarantee the cheapest. The answer might not be the lowest among these. Remember, the method's not perfect. Only the computer could do it perfect, takes too long, that whole thing. So you can't do that. You got to actually do the method. So what does that mean? What's the method on repetitive nearest neighbor? What method do I have to do? How's that different than nearest neighbor? Got to do it for all 5 letters. Does that make sense? So for repetitive nearest neighbor, you got to start with A, right? Which is what we just did. Start with A and go C, D. What is that? 4, 1, B, which is 8, and back to A, which is 9. And then add that up. What is that? 10, 8 to 22. And then you got to do it again starting with B, right? You just got to start with B. And go, okay, starting with B, what's my cheapest nearest neighbor? 2 to C, and 1 to D. And now there's no choice. There's only one city left. You got to go to A for 5, and you got to go back to B, which costly at 9. What's that, 10? That's 17. Oh, that's better. And then you got to do it with C, and then you got to do it with D. And then you pick the overall lowest, right? Everybody seeing that? So repetitive nearest neighbor, you got to repeat it for every letter. There's 4 letters, A, B, C, and D. You got to do nearest neighbor starting with, and then the overall winner, let's suppose it's this one. It's probably going to be that one. Is that the answer? I don't see it over here. Well, they rewrote them starting with A. But it is this loop. Do you see that? That's what confuses students. They think, well, look, they all started with A. I'm just starting with A. No. Repetitive nearest neighbor, you got to start with all 4 and then rewrite the answer in terms of A, right? So I would write it A, B, C, D. A, B. No, it's not quite A, is it?
No, I'm saying.
Oh, backwards. Yeah, you're right. Backwards. A, D, C, B. Yeah, A. No.
No, I'm saying A, B, C, D, and you have to finish with A, right?
A, B, C, D, A. Yeah.
Yeah.
Which one is that?
It's not up there.
Oh. Yeah.
It's not an answer, so it's not.
Oh, no, wait. A, C, B. Isn't it C? Because it's backwards? A, D, C, B, A?
Oh, okay.
Yeah, it looks like it's C done backwards. Of course, I didn't go on and finish. Maybe one of the other ones is cheaper. So maybe that's not the best. So anyway, we did about half that problem. Does everybody get the idea, though? I don't want to waste too much time. I'll make sure you get the idea. See the difference then between nearest neighbor, you just do it once, and repetitive nearest neighbor, you start with A and then B and then C and then D and then pick the winner and rewrite it in terms of A. All right. That is the difference between those two. Now, with all that in mind, let's do cheapest link. That's what I really came here to do. Let's do cheapest link. Can you guys do that real quick? So cheapest link, question 24, cheapest link. Go ahead and give it a try. Let me let you do the first part of it. So cheapest link. So which one up there is the cheapest link? I mean, and we're talking global. Remember, cheapest link means global. It means overall. Don't worry about whether it's at A or B or C. Don't worry about just what's the lowest number on the whole thing. It's the 1. It's clearly the 1. Then grab that road. So I'm doing cheapest link right now. So grab this. Whoops, what was that? Grab that 1 there. So that's the DC link, right? I'm just going to write DC. I think this will be helpful to write this down here, what I'm doing there. Okay, so I got the DC link. Now, what's the next lowest number up there? Yeah, the 2, which is the CB link. So I'll do the CB link. And see how I just connected it with the C? Rather than making it a new thing. Right, everybody with me? I had the DC, and then I got the CB. I didn't write CB because I already had a C. I just put the B on the end of the C, right? Everybody good so far? Now, what's the next cheapest number?
We can't go back on to D, right?
Well, 4, right?
4 is the next number,
Oh, yeah.
right? I'm just going up the line with the numbers, right? The lowest number's 1, the next lowest number's 2, the next number's 4. But should I take that one? You can't. Yeah, why not? I can't take that one because that's 3 lines hitting a city.
Okay, so
Remember the 2 no-nos. So when you do cheapest link, you want to remember the 2 no-nos. You can't have 3 lines hitting a city because remember, you just go into a city and out of a city. You don't hit it a third time, right? Just in and out. So no, you can't have that because you can't have 3 hitting a city. What's the other no-no? Well, we'll just keep going. So that's a no-no. I can't take the 4.
You can't go back to D. We can't take the 8.
can't move out.
Well, what's the next number?
9.
5, right?
5.
Oh, well, yeah. Oh, A, D.
Yeah, I should take the 5, right? So take the 5. Can't do the 4, but we can do the 5. And that's DA. So DA, I'll just put it down there, put it sideways, whatever.
A, B,
Good to there?
right?
B, C, B.
Now what's the next cheapest number? Looking at the map, I did a 1, a 2, I had to skip the 4. Did the 5, what's the next cheapest number?
Well, 8. But you can't.
8, right. You're thinking right, Cole, I'm going to get there.
Do 9.
Yeah. 8, if I took the 8, what would be the problem with the 8? That's the next cheapest number, but I can't do it.
3.
Yeah, it makes a loop with only 3 cities. It leaves out A. Does everybody see that? You might think, well, it hits A up there, yeah, but it doesn't loop through A. Right? See the problem? It makes a loop with just 3 cities. You can't, oh, and plus there's 3 of them hitting D now too, huh? It does both no-nos. Yeah. So you see how some of those are not allowed because of the 2 no-no rules, right? No 3 lines hitting a city, no loops that leave out a city. Right? It's supposed to be one big loop with all the cities. Now, having said all that, what Cole was saying is the quicker way to do it. So I was trying to reason with you, but let me give you the quickest way to do this problem now. Back to here, guys. Once we have only 1 city left, just to save time, don't do cheapest link anymore. Don't do any method anymore. Once you've only got 1 city left, you got to go to that city, and then you got to close the loop, right? No matter what the numbers are, no matter who your neighbor is, right? Save some time and some effort. Don't be wasting. That was all really ridiculous what I was doing. 4 and 8, 9. What? You got to go to A, and you got to close the loop. You got it, right? Because we're making a loop. So don't forget that. Whenever you get down to just 1 city left, it's real easy. Don't worry about what method you're doing. There's no choices. You've got to go to that city, and you've got to go home. And who's going to go to that city? It's got to be, it can't be C. C can't go to that city, right? It's got to be one of your end points. It's either got to be him or him. In fact, they both have to go to that city. The two open ends have to hit that city, right? Because we got to make a loop, and we got to have all the cities. So it's no question, boom and boom, for sure, required, no matter what my method. Does everybody see that? Make it as easy as possible. So the two, when you have one city, so when do you do that? When you only have one city left. So when you have only one city left, forget about the method. The two open ends, hit that city, done, right? No matter what your method, you got it. So once I get to this point, I've got DCB, you should think, wait a minute, I got 3, there's only 4, I've only got 1 left. The two open ends, whoops, I'm erasing. The two open ends have to hit A. There's no choice. They got to hit the missing city. That's my loop. That's my cheapest link loop.
So the answer would be A.
Now you can rewrite it all kinds of ways. You can rewrite it starting with A, and they all wrote them starting with A. So I'll go, okay, I'll rewrite the answer in the format they want, starting with A. You can go forward or backwards, like I'll go this way first off. A, D, C, B, back to A. Or you can go this way. I'll go A, B, C, D, back to A. Either one of those is the right answer. Is one of those there? Oh, yeah. Answer A is that first one, huh? There it is. Does that make sense how I did that? That's the cheapest link algorithm. Questions on that? So you just start with the lowest number, the next, but at any time, don't break the two no-nos. No 3 lines hitting the city. No loops that leave anybody out. And when you're down to 1 city, 2 open ends hit that city, for sure. So those are all the methods. I mean, that is the main meat and potatoes of this chapter, right? The nearest neighbor, the repetitive nearest neighbor, you do it 5 times or 4 times or whatever, and then the cheapest link. Those are the different ways. So know this, though. Make sure you catch this. None of those ways guarantee the best answer. I'm going to write that all formally out in a little while. But that's important even for test-taking skills. Catch me on that again. None of these methods guarantee that you're going to get the best loop to visit all these cities. None of them. So that means the student who comes in and tries to do the multiple choice thing by just adding them all up and picking the lowest, that's not right. Even if you pick the lowest, that's not the same as what the method will give you. It might not give you the lowest. Right? So I feel bad for the person doing that. I want to make sure we're clear on that. That won't work. You can't just come in here and go, well, I didn't learn those methods very well. I'm just going to add them all up and pick the lowest. No. That's the point. It's not the lowest. Remember, lowest would only come from brute force, the computers. Too long. So we have these methods instead. They're good, but they're not best. We'll talk about that. All right. Shall we move on? So there's the card. These will be quick and easy. If I look them up, because I don't remember. Well, what's this one say? Suppose solving a TSP. What's a TSP? Trolley salesman problem. That's this chapter. Anyway, suppose it's solving a TSP, use the nearest neighbor algorithm, find nearest neighbor, blah, 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 blah. Suppose you later find out that the cost optimal, blah, blah, blah. What was the relative error? Okay. What they're saying, suppose, so again, you get in the point that none of these methods are perfect. Brute force would be perfect, but it takes too long. So these methods are not perfect. They do not guarantee the best answer. So I got to give you this formula here. Relative, so they have error. They have error in them. And the relative error is time minus optimal time over optimal, yeah. Yeah. So none of the, only brute force would give you the best answer, but it takes the computers too long. So we have these methods which are not ideal. There's error. So how do we do this? We say, okay, so we did whatever our method, and we got a cost. It's going to cost FedEx $2,075 to deliver their packages. Okay? Well, it turns out there really is a better answer, which the computers weren't able to find, or the whatever wasn't able to find. $1,787. That would have been a better, cheaper path to deliver all the stuff. Okay, that's the optimal. So you take your time 2075, whoops, getting a little scribbly there. 2075 minus the optimal, 1787, over the optimal, 1787. You all have a calculator? So just subtract those and divide, and we'll get some kind of number. 213, 288 over 1787, I think, right? What's that come out to be? Some kind of decimal thing. Well, I guess there's the answer right there. So it must be 0.161?
Yeah.
Is that what it's coming out to be? And then remember, you move the decimal 2 places to turn it into a percentage. 16.1%. And that's our answer. That means there's a 16% error in that method with those results. Does that make sense? Everybody see what I did there? That means, you know, if the answer we got cost $2,075, the best answer would have been cheaper. We made a 16% error. That's the kind of thing management at FedEx would want to know. There was a cheaper way. We just threw away 16% of our profit, right? Because we didn't have the best way to deliver the packages, we lost some money. So that's why FedEx does, and UPS, they hire people and to write programs and to do the math to save them money. Make sense? How to do that? Right, good. Let's try another one like that. Everybody got that one down? If it's been a long time since you've done algebra. Okay, so same formula. What is that? Air equals, what was it? Time. Time minus optimal over optimal. Okay, so they're, on this one they're saying you find an approximate solution that costs $15.96. That's your time or your money. Time could be time or money. You know, it's all the same thing. So $15.96 minus optimal. I don't know what optimal is. Call it X. And the error is 6.4%. So that's 0.064. We have to solve that little equation for X. So everybody see what we're doing there so far? How are we doing? We okay? For what I'm doing up there? So the error, I just turn the percentage into a decimal, move it back 2 places, right? 0.064. And I write the formula, they gave me the time. I don't know the optimal. That's what they're asking, right? The cost of the optimal. So how do I solve that little equation for X, the cost of the optimal? What do I do? Does anybody remember? I'd be impressed if you remember that much algebra. How do we solve that?
Multiply by X first.
Yeah, good. You can do that way. That's a great way. I've found it's easy for students to just put this over 1 and cross multiply. Same thing as what Cole's saying, multiply by X. Either way, same result. So yeah, when you're trying to solve, you want to go like those two and those two. Diagonal. It's called cross multiply or multiply by X, same result. 0.064X equals 1 times 1596 minus X. Everybody see that? Diagonal. Cross multiply. And then when you multiply 1 times these guys does nothing. 1596 minus X, nothing happens there. We good? That's kind of scribbly. We good to there so far? What is that? Okay, let me bring it up here. Be easier to see. 0.064X is 1596 minus X. Now, how do I solve that equation? Here's the equal sign. It's like a wall. Remember algebra? X is saying I want to be alone. How do you solve that for X? Yeah, you got to combine the 2 X's together. You want to get rid of the lower one. So I'm going to add X, gonzo, to both sides. What happens on the other side?
It's just 1. So 1 line, 0.64.
Exactly. Yeah. Just Cole, remember algebra?
algebra.
Remember some of this stuff? Remember adding like terms 2x plus 3x is 5x? Remember that kind of thing from your algebra days? Well, over here, what Cole's saying is true. There's just a 1 really in front of that x, huh? So 1 plus 0.064 is 1.064x. Does that make sense? Last step to get x alone? Divide by the 1.064. And we'll have x. And I guess that's 1,500. Looking at the answer up there. 1,500. Bless you. Does that make sense there? That good? So practice that if you're a little rusty on some of that algebra. I promise I won't give it like a different look or anything. You know, I'm not expecting you to be a master of algebra. It'll be exactly like that. If it's on the test at all, it's not super likely. Well, there might be one. There might be one. And it would be just like that. So if you just memorize those exact steps, put it on your 3x5 card, you'll have it. I'm not going to pull special algebra questions out of the blue. It'll be just like that. Good on that one? Okay if I flash off of that? Get that copied down. Okay, so here we go. Basically, KN means complete. Remember we talked about this yesterday. I'm just going to give you formulas now. Complete graph in points. Complete graph means every city connects to every other city. Number of circuits. Number of circuits is n minus 1 factorial. Remember the exclamation point? Means like 5 factorial means 5 times 4 times 3 times 2 times 1 kind of thing. And then sometimes they'll also ask you number of edges, which is n times n minus 1 over 2. Okay, so put those on your 3x5 card for the exam next week. Let's crank them out. Let's do part A here. That's all you need. So part A says the number of edges in K9. K9. So number of edges. So we just take this little edge formula here and just put a 9 in and a 9 in. And just work it out. That makes sense? So it's n times n minus 1 over 2. So that's 9 times 9 minus 1 over 2. So that's 9 times 8 over 2. That's 72 over 2, 36. That's how I got the 36. Is that okay? Everybody see what I did there? So whatever this is the n, you know, whatever number they put below the k, that's the n you plug in. And for the edges formula, it's n times n minus 1 over 2. So I plugged into n times n minus 1 over 2. Put in a 9 for n in both locations. 9 times 8 over 2, 72 over 2, 36. Just use your calculator. Is that good so far? And then part B. Edges in K11. Edges in K11. Want to do that one? Same formula. I guess we didn't need this number of circuits formula yet. That must be the next problem. So plug in 11 for n. N times n minus 1 over 2. So it's 11 times 11 minus 1, or 10 in other words. So 11 times 10 over 2, 110 over 2, 55? 55 for that one. And then part C, it says the value of y minus x. What's all that? Oh.
You just do the same thing, but all you do is when you find the answers, you just do y minus x to get your answer.
Yeah. Right. Yeah, if you look up here, they're saying x is K31. y is k32. So you got to figure out y minus x means k, what is it, 32 minus k31. So you've got to basically plug into both formulas and work it all out. Here, I can do that on the next screen. Yeah, so for part C, it's going to be y minus x. Y minus x. Y, it says, is k32. And x up here, it says, is k31. So I don't know why they're using y and x. They could have just said, they're just being needlessly fancy for some reason. They're just basically saying, find k32 minus k31. And what is that? Well, remember, it's n times n plus, minus 1, huh? N times n minus 1 over 2. N times n minus 1 over 2. It's just we plug in 32 for this one, and we plug in 31 for that one. So 32 times 31 over 2 minus 31 times 30 over 2. Is that good? A couple big numbers. Somebody got that first number? Do my work, Carl. I'm just kidding. What's that first one? 496. Thank you. And the second one must be 31 lower. So 465. Subtract them, you get 31. They're asking what the difference is. Okay. So I just did K32, did K31. Whenever they ask for the K thing, for a number of edges, you just use the n minus 1 over 2, n minus 1 over 2 formula. Plug it in, crank it out. Right, good. So just formulas. Have them on your 3x5 card for the test next week. Is that good? Can I flash off of that? It'll be on the YouTube. I want to just make sure I use our time as efficiently as possible. Okay. Here we are. Okay. So on this one now, they're talking about, what are they talking about? Oh, find it. So Kn has 2 Hamilton circuits. So the number of circuits for Kn, what did I say it was? N minus 1 factorial. Yeah. So for example, if you have K2, that'll have 2 minus 1 factorial, which is 1 factorial, which is just 1. If you have K3, I'm just playing around right now. I'm not really answering the question. I'll get to that. Everybody see what I'm doing there? I'm just showing how you use this formula. So basically, if you have a complete graph, what Kn means again is a complete graph with 3 points. So that means if you have a graph with 3 cities, they're all connected, how many different loops are possible? Well, that's 2 factorial, which is 2 times 1, which is 2. Remember, the factorial means multiply all the way down to 1. If you have K4, then you have 4 minus 1 factorial, which is 3 factorial, which is 3 times 2 times 1, which is 6. And on you go, right? So they're saying, hey, you ended up with an answer of 2. Some kind of Kn had an answer of 2. That's what question A is saying up here. They're saying, tell me what n is, right? Find the value of n. If you had 2, so n must have been 3. N is 3. Am I confusing you there? Yeah. So they're asking the questions backwards. That's what's confusing. They're asking them backwards. They're giving you the answers, and they're saying, well, they're giving you the number of circuits, and they're saying, tell us what n is. So they're making us run these formulas backwards, basically. Right? So they're saying, hey, you ended up with 2 circuits. The number of circuits, the answer, these are all number of circuits. Right? The answer, the number of circuits, came out to be 2 circuits. So what was the n? Find the value of n. What was the number of cities that had 2 circuits? Well, I got the answer right here. For 3 cities. For n is the little number in the lower right corner of the K, huh? You with me? See the formula? See where the n sits? The n is the little number in the lower right-hand corner of the k. So the n is 3 here when the number of circuits comes out to be 2. So I just look and go, oh, 2 circuits? What was the n? What was the n? It must have been 3. So I just did it right here. I did K3, and it came out 2.
So you just have to play.
Yeah, I just did a couple of them and look backwards. Because it's like a backwards question. So you got to kind of do it and then look backwards. Let's try the next one. What for part B? That was part A. Bless you. For part B, it says 66 edges. Notice they changed the game. Not circuits, edges. So now we're switching back to the edges form. What was the edges formula? N times n minus 1 over 2. Remember that? They switched back to the edges formula. So they're saying, hey, the edges formula came out to be 66 edges. What was the n? Well, I could show you the formal algebra to do it. It's a little messy. I think it'd be better to guess. Sound funny to say, a math teacher saying guess? But no, guessing and checking is a good plan. Rather than a bunch of fancy, this isn't an algebra class. I'm not going to do a bunch of fancy algebra. So because they're asking a backwards question, you see what I mean? In the last problem, they gave me the n. And so yeah, I just plugged it in, right? But now they're working backwards. They want this to equal what? 68. No, 66? I can't hardly read that. 66. They want this to equal 66, and they're saying, what is in that makes that come out to be 66? Do you see what they're asking? I got to find the n that'll multiply to be 66. So just guess around. You got your calculator. That'd be quicker than going over reminding yourself of all the fancy algebra involved. We could solve that, cross multiply, distribute, get a squared equation. Squared equation, got to get 0. Factor, do you remember factoring? Got to do all that. Let's don't mess with that. Let's just say, hey, I don't know, maybe 10. What if n is 10? Well, then that would be 10 times 9 over 2, which is 90 over 2, which is 45. Is that too big or too little? It's supposed to come out 66. Came out 45. Am I totally talking to myself at this point? Am I making any sense? Is this making any sense? I'm just guessing. I'm just taking this formula and I'm going, hey, let me put in a 10. Right? It's always the number times one number lower over 2.
So we're trying
So I
to
just,
find out
I'm-
what is 66.
yeah, we're trying to find out what will get an answer of 66. Yeah, what in plugged in will get an answer of 66. That's what I'm trying to do. That make sense? Okay, let me go to a fresh screen.
Can we figure out what's half of 66? That's going to be...
You could do some algebra. It's just not going to be as easy. Number of edges, whoops. Number edges, n times n minus 1 over 2. You want it to, you see they said it came out 66. And they're saying find the n. What plug in will give you an answer of 66? See what I'm saying? It's making a little more sense now? So I said, hey, let me guess at n is 10. So then I put in 10 times 10 minus 1 over 2, and it came out 45. Too low. It's supposed to come out 66. Does that make sense? So then I'm going to raise my guess. All right, let me guess at n equals 15. Then it'd be 15 times 15 minus 1 over 2. Somebody got a number on that?
Try 12.
Isn't that 135? Too high. Yeah, so it's between 10 and 12. Let's try, 10 and 15. It's probably 12. Guess. So you just guess for a while. 12 times 12 minus 1 over 2. 32 over 2. Yeah, that's it, huh? Bingo. Ding, ding, ding. So what's the n? 12.
I'm just trying to find a way to speed this up.
I could show you the algebra real quick. Don't want to see that?
It's fine.
Does that make sense what we did there? I just guessed around till we had the n value that worked. right? Okay? Try C. Look at C. 19,503. Yeah, we don't got time for that. I'm gonna move on. There's other things I gotta do other things. I can't be playing around with that. So, yeah, so I give you that. The only other thing I need to give you is the information about relatives. So is that all good? Everybody good with that? So part C, you just guess more. All right, so I want to give you the word optimal. Optimal means gives best answer. So anytime you have anything in the math science world that has a technique to get an answer to something, and it's optimal, optimal means best, right? Optimal, that word means best. What's the other word they use? I forget. Optimal. Efficient. I know. What does efficient mean? Quick, right? So. Oh, I know what they use. They use approximate. So approximate means close, but not best. So optimal and approximate. They'll talk about which of these techniques are optimal, give the best answer, which are approximate, give a pretty good answer, but not the best. Which are efficient, which can be done quickly by computers, we mean. And which ones are inefficient, right? Inefficient is slow, even for a supercomputer. Okay, so here's the story. Basically, all the methods, what are they? The nearest neighbor, repetitive nearest neighbor, repetitive nearest neighbor, and cheapest link. All of those methods, all of those are approximate, meaning they're not optimal. They do not guarantee to give you the best answer. That's what I was saying earlier, so you can't just guess. They're not for sure the best answer. They won't. You could do them, get a pretty good answer, even cheapest link. And there's some other better answer out there that they couldn't find. Those methods are not optimal. They will not guarantee to always give you the best answer. But they are efficient. I can't spell efficient. I can't spell and talk. Efficient. There we go. But they are efficient. They're quick. For computers, I mean. I know they take us a long time. But I mean, you can write a computer program. That's what FedEx does. They write a computer program that does cheapest link. That does whatever, repetitive nearest neighbor. And cranks out an answer in 2 minutes. 1 minute for FedEx for that day for how to plan their route. It's not the best. It's not going to save the most money you could save, but it's pretty good. And they get an answer in a reasonable amount of time. There's only one way to get the perfect answer, and that's the brute force. Remember we talked about that one? Brute force means just do them all. Try every possible loop. And that's just too slow. Remember we did those numbers and then it was just huge. It's inefficient, even for the fastest supercomputer on the face of the earth, hundreds of years to solve some of these, even the ones doing trillions of computations a second. It's just too many loops. There's just too many different possible loops. So it's inefficient, but it would be optimal. If you let it finish its thing, you would get the very best loop, the cheapest way to deliver those goods. You would get the best answer because you looked at every possible loop. So you know you got the best one. So that's kind of the state of the science right now. That's pretty much modern right now where we're at. In other words, people are still looking. You could make big bucks if you went into this area. You'd have to be way smarter than any of us in this room are. But you'd have to be some super genius person and figure out a better way for, a program that more quickly finds the best answers and gives you better answers. FedEx would pay you all kinds of money because they would say
Do they
all
have
kinds of
one
money.
that like tries all the methods and creates an average?
An average wouldn't do it. We don't want an average. We want a method that's cheaper. Yeah. So you could probably research more. I don't know much more than I'm telling you, to tell you the truth. So I don't know. It's probably mainly my answer, Carl. So anyway, so we'll be asked about that though on the test. Does that make sense? They'll say stuff like the nearest neighbor. These are called algorithm. You know what the word algorithm? Are you familiar with that word? All of these are called algorithms. That's coming out of college. It'd be good to know that word. An algorithm is just like a series of steps. It sounds all fancy, but it's just a recipe is an algorithm. I always just call it a recipe. It's a recipe. What do? You just put in the flour, put in the sugar, put in the eggs and the milk, and put it in the blender and put it in the oven, you got cookies, right? It's the steps. All an algorithm is the steps to do something. It's a fancy word they use in the math science world. They say the algorithm, it's the recipe. It's the steps. So all of these are algorithms, right? We had a certain way of doing nearest neighbor, some steps. Each of these had steps, right? Procedure. So the way the question will come to you on the test is it'll say the nearest neighbor algorithm, which just means way of doing it, is an optimal algorithm. True or false? No, none of these three are optimal. Is efficient or not efficient, or the brute force is efficient or not efficient, or optimal or approximate. They'll ask you those kind of questions, and that is important to know the state of the science in right now. So there's no perfect method. You understand what I'm saying? FedEx would love to have better methods. I mean, they do the best they can with what they've got. And they use, I haven't researched it beyond this, but I'm sure they use some form of something like cheapest link, probably. And it's not the best. There's always better ways, which they don't have time to find because we don't have a way of doing it better yet. The brute force takes too long, even for the supercomputers. Does that make sense? That's the conclusion of that chapter. So you should be able to answer the questions on that. We need to start chapter 8. You guys okay with this 2 hours straight, me talking at you? It's going okay? Can you handle about 20 of these long lectures with no practice exam, no anything are long? They're just that they're long, huh? All right, chapter 8. So the next exam is 6 and 8. We skipped a couple chapters, which is what we were planning to do from the beginning. Teachers do. They, make a schedule for employees to do tasks. Well, we want to do that in the most efficient way possible. This is all about saving time, saving money, doing things quickly and efficiently, using math to help us do that. So here we go. Before we can dive in, we need to do the boring part of getting the tool ready, right? If you're going to suddenly work on something in your house, you got to have a couple tools. So same kind of way. If we're going to answer, the whole purpose of chapter 8 is management. How do we manage things efficiently? And to do that, we need these tools. Specifically, we need to get into what's called digraphs. So a digraph is shown on the right. And so what all digraph stands for? Yeah, I'm on the screen here. Whoops. Digraph is directed graph. Let me write that for you. So a digraph stands for directed graph. A directed graph, meaning you got an arrow. It's fancy talk, right? You got an arrow. So you're going a certain direction in the graph. Okay, so let's just get used to the tools here. We'll probably get to the real life problems Monday. So first off, the vertex set. That's fancy talk for what are the points? A, B, C, D, E. There's the answer, right? It's already on the screen. So vertex set means points, dots. A, B, C, D, and E. So it's just saying, hey, what are the dots in that little picture? Well, A, B, C, D, and E. It's called the vertex set, or the vertices. It's just the points. Okay, the arc set. The arc set. So that's the arrows. An arc is an arrow. So let's go back and list that out. So an arc is an arrow. So an arc is an arrow. So when they talk about the arc set, the arrow set, so looking at this picture, let's just start listing some arrows. There's an arrow that goes from A to B. Maybe I better use a different color here. There's an arrow that goes from A to B up there. Right? That's one of them. So I'm going to write AB. That's different than BA because it has a direction. Remember, it's a directed line. So you can't say BA. That would mean starting at B, going to A. So the order in which you put the letters matters because these arrows are directed. They're going in a certain direction. So I'm going to say AB because there's an arrow going from A to B, right? On that diagram. What's another one? How about A to E? That's another arrow on that diagram. Starting at A, going to E. How about A to D? That's an arrow starting at A, going to D. How about D to E? You can list these in it doesn't matter what order you list the arrows in, but every arrow must start where the dot is, and the second letter must be where it heads. So D to E, E to B, E to C, and C to D. So it's just listing them out. Pretty tedious, but I mean, it's not that bad. It's kind of boring. C to B. There we go. That's all. I just listed all the arrows. I just kind of drew them in as I went, so I make sure I didn't miss any. So they just want you to list those out. Any order, it doesn't matter. There they are. There's the arrows. Are we good on that? That's called the arc set, or the arrows. Stop me if you want to talk about this stuff. Then coming on down here, they want me to put what's called the in degree. The in degree. That means how many arrows are pointed in. How many arrows are pointed in to these various points. So, how many arrows are pointed in to dot A? Let's go back here to A. Let's see if we can answer that question. So, come on. So how many are pointed in at A? So does A have any arrows pointing into him? No, that's why it's 0. How about B? How about dot B? How many arrows pointing into B? 3, that's why it's a 3. C, just 1 arrow pointing in. Everybody with me? Am I going too quick? D, 2 arrows pointing in. E, 2 arrows pointing in. 2 going out. It's called the in degree. How many pointing in? Right? And yeah, that's it. That's it for that question. I guess.
No, it does the out degree.
Oh, does it? Okay. Let's do the out. Let's do the out degree. So what would be? Yeah, I don't know why they're not on the screen here. Let me get that copy down. Does that make sense? We good with all that? Okay. Let's go back. So same thing, just out degree now. So A has 3 arrows headed out of it. Right? B has no arrows headed out of it. C has 2 arrows headed out of it. D has 1 arrow headed out of it. And E has 2 arrows headed out of it. Like that. Good enough? Easy? So we just always begin with the basic tools we're going to use to do these jobs. So there they are. That's all we're going to do. Those basic tools. All right. Okay. So try that one. So how many arcs? What's an arc again?
The lines of arrows.
Arrow lines. Yeah, the arrows. How many lines with arrows are there? Is there 7? So 7, 1, 2, 5, 6, 7. There's 7 of them, right? Just count them up. There's 7. What's the sum of the in degrees? Well, if you think about it for a second, guys, if we know how many arrows there are, every one of those arrows has to be pointing in to something. So if we added up all the in points, it's got to be 7. There can't be more points than there were arrows. There can't be less. Every arrow has to lead to one thing pointing in, it also has to be lead to one thing pointing out.
Same thing without the group.
Yeah, it's going to be seven. It's a no-brainer question, right? If you think about it for a second. Right? It's got to be the same. Is that good? Because every arrow points in somewhere and comes out of something. Right? So all 7 arrows lead to an in degree and come from an out degree. All right. All right. Find all vertices that are incident to A. So what are a vertice is a point. Vertice is another name for a point. So which points are pointing in to A? Yeah, only the E. Only E points in to A. They're actually which points? Yes, I don't go EA because that would be
So it's just E.
that'd be an arrow. Yeah, they're not saying what arrows point in. They're saying what vertices, what dots, what letters. They just want you to say E. E points into A. Is that making sense there? Try that next one. Which vertices are incident from A? How many dots, again, vertices, we're looking for, not arrows, but dots. How many dots are pointed at from A? Just B, right? Yeah, just B. Just B, right? Right there, the only thing A points at is B. Coming from A. Which arc, now they're asking me for arcs. See how question C is asking me for arrows now. Which arcs are adjacent to BE. Now, what does that mean? Adjacent
Next
to BE. Yeah, adjacent basically means next to, huh? So where's BE? Oh, here's BE. Here's arrow BE, right? It's going like that. So which arcs are adjacent to? That means come after, I guess? Yeah, come after. See how EA comes after and ED comes after this arrow. So adjacent means comes after. Comes right after. Next to right after. Is that good? Easy little questions? Is that okay? Adjacent to BE, coming right after BE. Connecting after. All right. This is all just warm up, getting used to the tool of a digraph, because that's what we use to answer management questions. Consider the digraph with vertex set A, B, C, D, E, arc set right there. Without drawing the digraph, determine the following. The out degree of E. Got the answers already up there. So how did I know the out degree of E is 1? How do you look at that and know the out degree of E is 1?
It's the only arrow.
So out degree means out degree of E means how many arrows point out of E. Right? So out degree of E means how many arrows point out of E. So how many point out of E? How can you look at that and see? Is it cold in here?
A tad bit.
Open the door. It's quiet out here. Everybody else has left. It's just us in class now.
The whole campus.
That's right. The whole campus is deserted. Just Math 45. You crazy people taking these afternoon summer classes. And Friday afternoon. All right. So out degree of E. How many arrows point out from E? How can you tell? Can you tell right here? Here's the arrows, right? Right, the arcs, the arrows. So if you're going to point out at E, you got to be like E and then something else. So it's just that one, huh? That's the only one. It's just one. That's how we know there's only one, right? To point out, it's E pointing to B. There's no other ones that start with E. Make sense? Whereas the AE, that means A pointing at E. That's into E. In fact, that's the next question. How many are into E? Just one. There's the one in. There's the one out of E. This is into E, out of E. Good? Easy enough? Right. Okay, let's try it. Digraph on the right is a respect graph. Digraph. That is, vertices of the digraph represent members of the group. X, Y represents X respects Y. All right. Da-da-da. All right, so to get what this means, first off. So the arrows, so they're trying to use this to do like social relationships, right? So like E points to A. What does that mean? E respects A. That's what that means. B points to A, which means what? B respects A. So if you point to somebody, you respect them. So they took these 5 people, A, B, C, and D, and they say, hey, who respects whom? And they just did arrows. If you respect somebody, you got an arrow pointed at them, right? That's what they're describing up there. Here comes question A. If you had to choose one person to be the leader of the group, whom would you pick? Explain. Well, I answered already. Person A would be the leader. Why am I picking A to be the leader? Because he is respected by the largest number of people in the group. Right? Largest number. Nobody else has 2 people pointing at him, 2 people respecting him. B, who would be the worst choice to be the leader of the group? And I said D. Why is D the worst choice? Everybody see that? There's D. D, nobody's pointing at D. Nobody respects D, right? Nobody's pointing at D. Nobody respects D. This is like a sociology graph or something.
Visualize.
Visualize, yeah, social network relationships here. Using math, right. All right. That's right. Yeah, you could do this at your next social gathering. Say, hey guys, let's draw a map of the social relationships here.
Probably call me a crackhead or something.
That's what I always do at all my social gatherings. I don't know why I don't have many friends. No, I'm just kidding. All right, so let's go on to number C. Letter C. Assume that you know the respect digraph of a group of individuals, and that is only information available to you. Which individual would be the most reasonable choice for the leader of the group? Yeah, we already.
Largest in the group.
Yeah, we kind of already answered that, didn't we? I guess they're just saying it in other words. Largest in degree. Largest in degree. All right, is that good for a warm-up? You want a clicker quiz here?
Maybe.
Let me do that.